So first thing this morning, let's start with our angle warm up, okay? So somebody give me the value, oh, I already have the answer on the screen. Can you calculate the angle of X in the first triangle, please? I know the answer is there, and I want you to round the answer to 3 significant figures, but I want you to calculate it for me, please. Now, you remember this is only using trigonometry. So, first of all, we have an angle 68 degrees. X is the what? 3 significant figures, Janae. X from 68 degrees, X is the opposite, and we have the hypotenuse. So the value of X will be what, guys? 21 is the base of the entire triangle, but we're not worried about the 21 base because that's not what we need for this triangle. Remember, this is the triangle we're worried about right now, guys. Oops, sorry, my pen just went off the stage. This is the triangle we're worried about. Anybody have an answer for me? Yes, Rakia, Latea, we're using sine, correct? We're trying to find the height of this triangle. Okay, guys, we're running late, so we're not going to be able to go long into this morning. So this is our warm up. In order to find the value of X, this is what I'm talking about right here. This X right here, guys, going straight up and down, this is X, okay? We're going to use SOHCAHTOA. We have the angle 68 degrees, which is right here, and we have the hypotenuse, which is right here, okay? So X is the opposite, and the hypotenuse, the trigonometry that we would need would be sine, which is opposite over hypotenuse. So the sine of 68 degrees will be equal to X over 8. Okay, everybody's got that? And that's where we will come up to 7.41747. The 3 significant figures, it'll be 7.42. Somebody give me the value of, look down to the bottom triangle. Somebody give me the value of, we're only going to do one. We're going to do the Z. Somebody give me the value of Z in the second triangle, please. Okay, no, sorry. Give me the W in the second triangle. Give me the W, please. Because that way we can just work that without having to get any other information. So if from the angle, from the triangle, we look at it, we're talking about this second triangle. If those who are not following, we're talking about this second triangle down to the bottom here. And we're looking for the angle of W. Remember, when we're solving for an angle, we will use the inverse formula. Remember now, we're looking for W. So if I look at what I have, okay, if you look at what I have, okay, everybody else, you'll see that I'm looking for angle W down here. I also already have the information that they gave us is that I have the 5 and the 13. Well, from angle W, 5 is my adjacent and 13 is my hypotenuse as always. So I will set up my formula to be, I'm looking for the cosine, and it's going to be to the -1 because I'm looking for the inverse, and that will be adjacent over hypotenuse. My adjacent is 5 divided by my hypotenuse, which is 13. Okay, and that will give me 67.4. 67.4 if I round it up. 67.38, which is approximately 67.4. Okay, today the lesson will be on angles of elevation. Okay, somebody's asking if the online calculator has sine, cosine, and tan. It probably does, but it is best to use your actual calculator because you need to get familiar with the calculator you will be using in exam and in class. And as you know, you cannot use a laptop, a tablet, a phone calculator on the exam. Angle of elevation is the angle measured from a horizontal line of sight up to an object. So that means that if I'm looking straight ahead and I look up, that's my angle of elevation. My angle of depression is the angle measured from a horizontal line down to an object. And a lot of students get confused about what is horizontal and what is vertical. I always like to tell my students, angle, if you want to know horizontal, imagine you're out there on the beach looking out at the horizon. Once you're looking at the horizon, it's a straight flat line in the front of you going from left to right. That's your horizon, okay? So anytime you're looking at the horizon, that's what you have to remember. That is what we're calling a horizontal line, a line that goes straight ahead, left to right. It doesn't go up and down. So this will be from the young lady here watching this balloon. Angle of her horizontal line will be from her sight straight ahead. Her angle of elevation will be the way she's looking up at the balloon. That was between not the ground, but her eyesight to the balloon. Now, her angle of depression looking down would be from the balloon looking down at her. So if somebody's in the balloon looking down at her, they would have what we call an angle of depression. And if you notice, and if you could remember back, they are angles of, the angle of elevation and angle of depression are alternate angles. These measures are equal. And if you go back to your junior high school geometry, angle of alternate angles look like a Z. So you see that clear Z shape there. Everybody can see the clear Z shape. Okay, is angle 1 an angle of depression or elevation, guys? Angle 1, is it in elevation or depression? Angle 1 is the depression. Excellent, excellent, excellent. How about angle 2? How about angle 2, guys? Elevation, Shaquani, great. Great, Rakia, great. Jason, Shanae, excellent. Now, let's get tricky. How about angle 3? How about angle 3? Oh, yes, Akil. Yes, Elton, great job, Jason. Deontay, Sebastian, I see you. Rakia, Janae, great job. Eric? Horizontal, what angle would that be? Okay, Alex, not quite. We're talking about angle 2, angle 2. I'm sorry. How about angle 4, guys? What is 4? Ah, yes, Akil, angle 4 is elevation. Because from that point, we're looking up at this person, so that will be a 4. Great job, guys. Okay, let's look at our first example. The first example said a man standing 50 feet from the trunk of a tree makes a 53-degree angle of elevation to the top of the tree. What is the height of the tree from the man's line of sight? So the first thing we always like to do is draw a diagram. Without a diagram, we always lost. So when we draw the diagram, here's the man standing. Here's the man standing here, okay? And from his height to the top of the tree, it makes a 53-degree angle of elevation. What is the height of the tree from the man's line of sight? What is the height of the tree from the man's line of sight? Okay, so that means if he's standing 50 feet from the tree, then, okay, his 53 degrees means that A, the 50 feet will be my adjacent, and the height of the tree, what we are asking for, would be my opposite. Which trigonometry formula uses opposite and adjacent, guys? Not quite, Sebastian. Great job, Latia. Tanya, Sebastian, Richmond, Raven, Janae, Tan. Not close, guys, not close. The only formula that uses only adjacent and opposite is the tan. Great job, guys, who answered tan. So let's start with our formula. We always start with formula. That keeps it oriented, tells me what to do next. That's our plan of attack, our formula, which is the tan of angle theta equals opposite over adjacent. Next, let's substitute. We're looking for tan for 53 degrees is equal to x over 50. Next, let's go and we reorient my formula to have x as a variable by itself. Now, tan of 53 times 50 will give us 66.352 feet. That's equal to x. I rounded to the nearest whole number. Yes, Letitia, great job. Rounding it to the nearest whole number gave me 66 feet. Any questions about that part of angle of elevation? Okay, that was a really good one. Rakisha, great job. Letitia, good job, great participation. Okay. Yes, it is pretty easy. Once you understand that it's just an offshoot of trigonometry, we're using the same terms, we're using the same information. It is pretty easy once you understand trigonometry. So my next question, a sailor is 100 feet away from a lighthouse. The angle of elevation from the sailor to the top of the lighthouse is 50 degrees. Sorry, what is the distance from the sailor and the top of the lighthouse? So, you know, Ms. Knowles likes to start our thing with a drawing, and that's always best, so we could understand what we're saying. Here's the sailor, he's looking at his lighthouse. He's looking at a 50 degree. So we want to know what is the distance from the sailor and the top of the lighthouse. That means that we're looking for the hypotenuse. Okay, which formula uses adjacent and hypotenuse? We're a little too quick on the mouse button. I'm trying to get through this before we have to say goodbye. Okay, so cosine, everybody, yes. Fill in what we have. So we'll have the cosine of 50 degrees is equal to 100 over x. Now remember, the little trick with when we have x in the denominator, switch the cos 50 and the x. Okay, so that will give us x is equal to 100 divided. Great job, Letitia. We're going to divide. So this is our x. X is equal to 156 feet. Any questions about that? Round it up. Okay, great job, guys. And so let's go. I'm going to skip this example tree, guys, because I want to go to Okay, here we go. How tall is the flag? This is an interesting question, because what will we have to find out first in order to find out how tall is the flag? The height of the building. Excellent, excellent, excellent. So we have to find out not only the height of the building, but what kind of angle it is. Yes, Rukia, with the angle of, everybody knows this angle of elevation, correct? So from our viewpoint, does anybody else see what would be tricky about that? I have to do two calculations, correct? How tall is the flag? Okay, the first thing I would have to then do is find out how tall is the building and how tall is the flag and subtract the two. Yes, yes, Richmond, exactly. I have to do two calculations. I have to do one where I would find out the height of the building using 30 degrees. And then I would have to find out the height of the flag using 32 degrees. And from those two, I would have to then do a subtraction for the information. Great job, great discerning, Richmond. Okay, now thank you for joining us today. I will post this on the website today, okay? And this is one of the BGCSE questions that we normally have. This too will be posted. If you have the ability to take a screenshot, it would be excellent to do so at this time. It will be on the Ministry of Education's virtual learning website. All the resources that you see us use, the PowerPoints and the worksheets, all the links are on the Ministry of Education's virtual website. Okay, you guys have a beautiful day. Thank you very much for joining us.
Hey, it's time. Gather around. Come on now. Let's sit down. It's time for mathematics. It's time for mathematics. It's time for mathematics. It's time for mathematics. Hi there, guys. Glad to see that you could join me again for another magnificent and marvelous math lesson with Miss Antonia Bain. Boys and girls, today we're going to be using our super brain powers to find the area of squares and rectangles. Let's take a look at our lesson objectives. By the end of this lesson, students will be able to find the term area, state the formula for finding the area of squares and rectangles, and calculate the area of squares and rectangles. Let's look at the definition of an area. Read with me. Area is the amount of surface space that a flat object has. Area is reported in the amount of square units. Ever thought about how much space your rug takes up? Well, that's the area. And to find the area, we can do one of two things. One, we can count the squares. If we have a shape like this, to find the area, we count the number of squares. Based on this shape, we know that the area is 9 centimeters, but not just 9 centimeters, 9 centimeters squared. And that's because area is measured in square units. Let's look at this shape. To find the area of the shape, we count the number of squares. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That means that the area is 15 square feet. Awesome job! You superheroes are doing super duper today. But look at this. Suppose you have a problem. Two neighbors build swimming pools. Below is what the pools look like. Which family has an area of 8 square centimeters? Remember to find the area of a shape given square units. We count the amount of squares. Is it family A or family B? If you said family A, you are correct. Awesome job, superheroes. Well, that's the first way, by counting the squares. The second way for us to find the area is to multiply the length times the width. So, we have a shape like this. A rectangle. The area is the length times the width. So I multiply 5 times 3. 5 centimeters times 3 centimeters. And I get 15 centimeters. But not just 15 centimeters, 15 squared centimeters. Let's try another one. I'm given a shape like this. 7 centimeters, 7 centimeters. Can anyone guess what kind of shape this is? Yes, it's a square. How do we know that? Because all sides are the same length. To find the area, we multiply the length times the width. And based on our shape, the area would be 7 times 7, which gives us the product of 49. So my area is 49 centimeters, but not just 49 centimeters. You said it, 49 squared centimeters. Are you superheroes ready to go on a quest? Do you think you can find the area of these shapes? Let's give it a try. What is the area? Is it 40 square centimeters or 80 square centimeters? If you said 80 squared centimeters, you are correct. Awesome job, guys. What about this? What is the area of this shape? If you said 120 centimeters squared, you are correct. You're doing beautiful. Absolutely beautiful. Try this last one. What is the area? Is it 22 square centimeters or 24 square centimeters? Think hard. If you said 24 centimeters squared, you are correct. Awesome job. You're doing very good at this, superheroes. So now, let's do our review. Today, we talked about area. We learned that area is the amount of surface space that a flat object has. The formula for the area of rectangles and squares is length times width. And don't forget that area is reported in the amount of square units. You guys are now area heroes. You got it, you got it, you got it going on. Awesome job today, guys. Go forth and be great in the area of area. This lesson was created by Miss Antonia Bain. Hi there, guys. Glad to see that you could join me again for another magnificent and marvelous math lesson with Miss Antonia Bain. All right, boys and girls, get ready for another exciting math lesson. Today, we are focusing on area of a triangle. Let's take a look at our lesson objectives. By the end of this lesson, students will be able to define the term area, state the formula for finding the area of a triangle, and calculate the area of triangles. Let's do a quick review. Last lesson, we learned about finding the area for squares and rectangles. Can you remember how to find the area? What is the area of the shape shown on the screen? Remember, to find the area, we must multiply the length times the width. That means 10 times 6. 10 centimeters represents our length and 6 centimeters represents our width. Once we multiply those factors, our product is 60 centimeters. But not just 60 centimeters. That's right, boys and girls, 60 square centimeters. Now, let's look at area of triangles. To find the area of a triangle, multiply half the length times the height. Now, you may hear this word interchanged. Length with base and height could also be changed with the word width. Half length times height or half base times height. But what does all of this mean? Let's take a closer look. Remember, the formula for area is half the length times height. In this example, 8 centimeters represents our length and 4 centimeters represents our height. So, let's write out our formula. The area is half 8 times 4. To solve this, we must first multiply 8 and 4. Those are our factors. When we do that, we get a product of 32. Now, we need to divide 32 by 2. That's the same thing as saying half of 32. When we do that, we get 16 centimeters. But we're not finished yet. Remember, area is measured in square units. So our final answer is 16 square centimeters. Let's take a look at another example. How do we find the area of this triangle? Remember once again that the formula for area is half length times height. In our example, 8 centimeters represents our length and 8 centimeters represents our height. So let's write up our formula. The area is half 8 times 8. First, we must multiply our factors. What is 8 multiplied by 8? Yes, that's 64. Once we do that, we ask ourselves, what is half of 64? Or 64 divided by 2. That's the same thing. When we do that, we get 32 centimeters. But of course, we know that area is measured in, that's correct, square units. So our answer is actually 32 square centimeters. We have one more example. What's the area of this triangle? Again, to find the area, we use the formula half length times height. In this example, the length is 2 centimeters and the height is 4 centimeters. Let's write up our formula. Our area should look like this. Half 4 times 2. Now, we multiply. Let's multiply the factors 4 and 2. 4 times 2 gives us a product of 8. Now we ask ourselves, What is half of 8? Or what is 8 divided by 2? When we do that, we get the number or the answer 4. 4 centimeters. But of course, area is measured in square units. So that means that the answer is actually 4 centimeters squared or 4 squared centimeters. I wonder, can you find the area? Do you think you can give it a try? Let's see. What is the area of this triangle? Remember, the formula for area is half length times height, or half base times height. We can use the words length and base interchangeably. So, what is the area of this shape? If you said 20 centimeters squared or square centimeters, you are correct. Let's try another one, boys and girls. What is the area of this shape? Remember, area is half base times height, or half length times height. Yes, that's correct. 150 square centimeters. Try this last one, boys and girls. What is the area of this shape? This one may be a doozy. We're multiplying decimals. That's correct. We learned this last week, didn't we? So you should know how to multiply those decimals and where to place that decimal point. That's correct, boys and girls. 2 1/10 centimeters squared or square centimeters. You are doing awesome. Your brain is percolating. Beautiful job. Now let's do our daily lesson review. Today we learned about area. We said that the area is the amount of surface space an object occupies. We know that the formula for the area of a triangle is half the length or base times the height. And of course, we are to always remember that area is reported in the amount of square units. Boys and girls, you did a very good job today. I'm almost sure that you can now find the area of any triangle that's given to you. And because of that, you are going to be area masters in no time. This lesson was created by Miss Antonia Bain. Hi there, guys. Glad to see that you could join me again for another magnificent and marvelous math lesson with Miss Antonia Bain. All right, boys and girls, let's learn how to find the perimeter of compound shapes. Let's take a look at our lesson objectives. Today, we're going to learn how to calculate the perimeter of compound shapes and how to solve word problems involving finding the perimeter. Let's do a quick review. In our last lesson, we learned that the perimeter of an object is the distance around it. We also talked about the units of length used to measure perimeter. Some of these units include millimeters, centimeters, meters, kilometers, inches, feet, yards, and of course, we can't forget miles. Let's do a quick review. Do you remember how to find the perimeter of a shape like this? is correct. Count the sides. Count with me, boys and girls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The perimeter of this shape is 14 centimeters. Awesome job. What about this? How do we find the perimeter? Do you remember? That's correct. We add up all the sides. So when we do that, we should have 8 plus 8 plus 3 plus 3. Of course, we can't forget our units. So that's 8 centimeters plus 8 centimeters plus 3 centimeters plus 3 centimeters. And when we do that, we get a total of 22 centimeters. Now, let's talk a little bit about a compound shape. What is a compound shape? Well, a compound shape is a shape that can be cut into other shapes. Let's take a look at our example. Can you see where we can cut this shape to form two shapes? Yes, that's correct. That's one of the places where we can cut it so that it forms or makes two separate shapes. That's how we get a compound shape. But how do we find the perimeter of a compound shape? Well, to find the perimeter of a compound shape, add up the lengths of each side. Let's look at this shape as an example. There are 1, 2, 3, 4, 5, 6 sides. So our formula should look like this. Side plus side plus side plus side plus side plus side. Now, let's replace each of those sides with a number representative. So that's 12 centimeters plus 11 centimeters plus 8 centimeters plus 7 centimeters plus 20 centimeters plus 18 centimeters. When we add all of that up, the perimeter should equal to 76 centimeters. That's correct. Now, boys and girls, there are times when we're not given all of the sides. But there's still a way that we can figure out what the perimeter is. Let's take a look. First, we must always write down our formula. In this case, our formula is side plus side plus side plus side plus side plus question mark. And I put that question mark there because that represents the unknown side. Now, we must fill in the information that we know. We know the length of all of the sides except the unknown side. So, now that's 6 plus 2 plus 10 plus 9 plus 4 plus question mark. And remember, the question mark represents, that's correct, the unknown side. Awesome job, guys. Let's now try to figure out what's the length of this unknown side. How do we do that? Let's see. Can you identify the sides that are parallel to the unknown side? If you said this side and this side, you are correct. Once we've identified those parallel sides, the next thing we must do is subtract the smallest side from the largest side. When we take 2 from 9, we get 7. So we can now fill in the missing information. Our formula should look like this. Now, it's time for us to add up the length of all of the sides. And when we do that, we should get a total of 39 centimeters. But wait, what happens when you don't know the length of two sides? Well, don't worry. I'm going to show you how to solve this one right now. We do it the same way. First, we must write out our formula. So let's go. Our formula should look like this. Now, let's fill in the information we know. 6 plus 4 plus unknown plus 15 plus 10 plus unknown. Now, we need to figure out the length of the unknown sides. Let's begin with this side. Remember we said to find the length of the unknown side, we must look at the sides that are parallel to it. Which sides are parallel to the unknown side? Yes, that's correct. 10 meters and 6 meters. Remember, once we identify that, we then have to subtract. And when I take 6 from 10, I'm left with 4. So let's fill in that information. The length of my first unknown side is 4 meters. Now it's time to figure out the length of my second unknown side. To do that, I identify the sides that are parallel to it. Which sides are parallel to the second unknown side? If you said 15 meters and 4 meters, you are correct. Now we need to subtract. When I take 4 from 15, I'm left with 11. So the length of my unknown side is 11 centimeters. My formula should look like this now. Awesome! The only thing that's left for me to do now is that's correct, add up all the sides. And when I do that, I get a total of 50 meters. Do you think that you're ready to go on a perimeter search? I think you are. Let's see if you can identify the perimeter of these shapes. Which shape has a perimeter of 20 centimeters? Look at the shapes very carefully. Remember, when we find the perimeter, we're adding up all of the sides. Is it shape A or shape B? If you said shape B, you are correct.
Let's give it another try. What is the perimeter of this shape? Is it 22 centimeters or 13 centimeters? Look very carefully because we have some unknown sides here. And of course, we know how to figure that out. So I'll give you a minute. Find the perimeter. If you said 22 centimeters, you are correct. Awesome job, guys.
What then is the formula for calculating the perimeter of a rectangle? Look carefully. If you said A, you are correct. Awesome job, guys. I'm super proud of you. Let's do a quick review. We learned quite a number of things today. We learned that you must add to find the perimeter of a compound shape. We also learned that to find the length of an unknown side, look for the lines parallel to it and subtract the smallest side from the largest side. And of course, we cannot forget that we must use units of length to measure perimeter. You did awesome today, guys. This lesson was created by Miss Antonia Bain.